All right, welcome everybody to the Atlanta.net users group, August COVID edition. And I am your host, Ken Ross, as usual, coming to you live from my virtual home office. I don't have a whole lot of community announcements. In fact, I don't know that I really have any other than to say that I hope you're all doing well, staying safe and healthy in these weird and wonderful times we find ourselves. We're going to continue doing this virtual thing as long as we need to, and probably try to keep doing it even when we don't need to, because I think it's just nice to be able to reach out to everybody who can't necessarily make to the meeting in person, as well as allowing us to bring in new speakers that may not have been open to us before because they couldn't travel. So we're going to keep doing this. And so without really much else to say on my part, I'm going to turn this over to Samara.
Okay, let's see here, screen share. And pull up. All right, so welcome to Azure Functions and Functional Programming. Thank you for coming. Just kind of the beginning housekeeping things. My name is Samara Soucy. I am a software engineer currently working with Microsoft. I work for Azure Customer Experience Community Engineering. Basically, it's a fancy way of saying I answer questions for you on Stack Overflow and among a few other platforms. That is my Twitter and my Microsoft email. If you have questions, either you don't want to answer them as part or ask them as part of this presentation, or for whatever reason I'm not able to get to them, please feel free to reach out to me. My GitHub is also One Angry Penguin. All of the code I'm going to show and these slides are in my GitHub, and the link to the repository will be in the resources slide at the end. So one last little shout out. We are building up a new office here in Atlanta. Putting together 2 buildings are being built for us at Atlantic Station. Been with it since almost the beginning, about 1.5 years ago. And we are definitely hiring, and we want to hire local people if where possible. So if you have been looking to join Microsoft and been thinking about it, especially if you don't want to move to Redmond, it's a great time to do that. Careers.microsoft.com is the website. If you go in the search box and type in #MicrosoftATL, that will bring you the jobs that are located in Midtown. Also Twitter and Instagram at MicrosoftATL. If we have any events, including hiring events, they'll pop up there as well. If you have questions, please feel free to interrupt me, post in chat, raise your hand. I am watching chat, and so hopefully I will catch it. Otherwise, Ken will poke me and make me stop and answer your question. All right, so let's get going. So if you're like me, I use what customers use being on Stack Overflow, which is mostly C#. I don't do a whole lot of functional programming or F# in my day job, and you're not sure what it means. We'll start there. So there's a lot of different definitions on the web. People are very opinionated about what functional programming is. This is what I put together after reading quite a few of those different conversations about what it means to do functional programming. So first point is that your primary purpose as a programmer is tell the computer what you want, not having to deal with the details of how that happens, letting, in the case of F#, the compiler handle as much as possible for you. So you can, a lot of times, get things done faster with fewer statements. Second item, variables are immutable. You cannot change them after they have been declared. And third one, this is kind of the weird one. Functions will always return the same output for the same input. So if I have a function that takes integers x and y, returns x plus y, It's a pretty basic example. If I put in 3 and 4, I'm always going to get 7. Even simpler example I have there, if I have a function called get 8, it's always going to return 8. I don't have any inputs there. And the other aspect of that same idea is no side effects. And kind of the test for that is that whatever the return value for that function was, I can put that back into the program and it doesn't change the function, how the program runs at all. So again, simple example, it always returns 8. I could go back to where I'm calling that function and just put in 8 there and it would have the same impact. Just to have the x plus y example, instead of having an addition function, I can put x plus y back into the place where I'm calling that function, get the same result. Those two things, second and third things, are where people tend to push functional programming without side effects, without a whole lot of changes. You do get some advantages with things like thread safety. You don't have somebody changing a static variable 3 layers deep, and all of a sudden everything breaks, and you've lost your weekend. Super fun times. So, and immutable, and the other side effect of this aspect of this is that it makes it very easy to test. If the same input always gets the same output, running your test cases becomes very simple. And the last point is considered a requirement for functional programming, but a lot of languages have this, including things like C#, and that's that I can use a function as an argument for another function. Terminology there is higher order functions. As far as F# specifically, which is the language that I'm talking about today, quick history if you've never heard of it before. If you want the longer version of it, on the F# org site, F# Foundation site, anyway, there is a fairly long paper, I think it's about 75 pages, detailing a whole bunch of how this came about, why it came about, some of the conversations that happened behind the scenes. If you're into that kind of thing, it's really interesting to read. Obviously, I'm not going to go over all of that, but the quick version of it is initially released, .NET was initially released in 2002. F# came out in 2005, just a few years later, by Microsoft Research. And the primary goal was that they wanted a functional language within the .NET ecosystem. At that point, we had things like C++, C#, VB, but we didn't have a functional first language. Originally, it was an implementation of OCaml. So you're going to see a lot of influences from that language if you've ever worked with it before. Certainly since then, it's influenced and has been influenced by a whole lot of both object-oriented and functional languages, but that's kind of the foundation. Interesting to me, at least, was back in 2010, before even .NET Core came out and we really embraced the open source .NET, F# actually went to open source under Apache 2 a few years earlier than that. And last thing, if you're wondering who in the world actually uses this language, if you've never heard of it, never seen it used, functional programming in general is considered fairly strong for things like data analysis and modeling, and it's been embraced particularly by the finance industry. So that's where there's certainly quite a few places that use it, but the majority of them come from that area. Just a couple of thoughts on being a C# programmer and going to an F# and trying to figure out how to do this new language. When I'm going to say, when I'm learning, say, C# to JavaScript, C# to Python, things that are both object-oriented, it's possible to do a little bit of a one-to-one translation, right? I can take my C# code and kind of look at it and go, okay, these are my models, I'm going to rewrite my models, here's my functions, those things. When you're moving from an object-oriented to a functional language, F# is not pure functional. You can absolutely write object-oriented style programming in F#, and it's somewhat required because of .NET. I'm going to encourage you, though. I did get a lot out of writing code in C# and then trying to write the same code in F#, but it's good to take a step back and instead of trying to do a one-to-one translation, kind of look at the problem again and look at the kind of quote-unquote F# way to do it. The other note that I have here, I think the biggest thing that helped me kind of get it, go from that kind of abstract definition to what it actually looks like in real life. If you have used LINQ, which if you have used C#, you've probably used LINQ at some point. That is actually written in a functional way, right? So if you've written LINQ, you've written functional code, even if you didn't know it, right? So, if I look at a LINQ statement, data, where, select, first, all those kinds of things, the data variable doesn't change. It's got this kind of pipeline thing where it's the results of one function get pushed into the next function, into the next function. I'm not telling LINQ how I want the thing to be actually done. In the case of something like LINQ to SQL, LINQ does one translation layer, and then the SQL engine does another translation layer to try and figure out how to actually physically go get that data. And I'm not deciding on any of that, right? All I'm saying is I want this data, these pieces of this data, and I want the first result. And the last point here, I didn't include it in the example code, but if you've used LINQ, you've seen this, the delegates that go inside of each of those function calls, which is passing a function to a function, right? So it's very, very similar to what you would expect from a functional language. So you absolutely can, I think I mentioned, write C# code in F#, essentially just kind of changing out some of the syntax so it fits with F# to the point where if you're using a C# type, F# starts to get a little bit more flexible with some of the syntax and let you use the C# style syntax. In general, though, if you can, again, it comes back to that. If you're just going to write object-oriented code, go ahead and use C#. That's what it's built for. But so if you're trying to solve a problem in F#, try and think about it in a functional manner and use the F# type classes. The C# types are there so you can talk back and forth with C# without having too much hassle involved. So the other half of that equation is Azure Functions, right? And what is Azure Functions? First off, it's the best product in all of Azure. There are many, many good products in Azure. I do have a few favorites though, for sure. Kind of the formal designation is it's a platform as a service offering. Idea being that you as a developer can focus on just the parts of the code that define what you need it to do and worry less about systems or boilerplate or anything like that. There's a, uh-oh, can't see the PowerPoint.
Well, most can, but some can't.
Interesting. Let me, you know what? Let's just in case. Let me stop sharing and then start sharing again, just in case.
Yep.
All right. We'll see if that helped people.
Looks like it did.
Cool. Awesome. All right. So Azure Functions, platform as a service product. Helps you be a more efficient developer, essentially. Kind of in the range of we take care of everything, but still fall under platform as a service, to we take care of just the bare minimum. It's kind of in the middle. Traditional app service being on the side of we don't do as much, and then logic apps being kind of on the extreme where you're actually not doing any real coding at all at that point. You're just drag and dropping in a UI. So in addition to the basic platform as a service, where we handle server maintenance and things like that, Functions handles a couple other things for you, which as a developer makes my life much simpler. One is on some of the plans, most of them, in some fashion or another, we handle scaling. And for quite a few different services, some Azure, a couple not, we'll actually handle making the connection to, say, like a Cosmos DB service for you, so you don't have to write all that basic, I want to connect to Cosmos DB, and I want to connect to this database, and I want to connect to this container under that database. We take care of a lot of that for you. Make sure so you can focus, like I said, just on that little bit of code that actually does what you need it to do. From a billing standpoint, because money matters, there are a few different ways to deploy functions to Azure. I kind of group them into two sections. One is kind of your basic pay by the hour, pay for the VM that you're running, and that comes in the form of app service. Or fairly recently, we started letting you deploy functions to a VM itself and use it on an infrastructure as a service style setting, where functions gets to be more powerful and usually less expensive, depending on what you're doing, is the consumption style plans. And the idea there is that if I have a website that sits idle for 29 days out of a month, and one day a month gets a bunch of traffic, right? If I'm running that website all the time, I'm paying for that website 100% of the time. In Azure Functions consumption billing, those 29 days, you'd have maybe a minimal charge because it has a storage account behind it. You might have a little bit if you have always on turned on, but for the most part, you're paying very, very minimal amount of money. Close, we'd like to say it's nothing, but like I said, there's a storage account and a few other things. So I'll say it's usually about pennies, right? For those 29 days, and then that one day, while it's being used, you pay for that CPU time. And because it's automatically scaling for you, it might be 4 or 5 copies of that application. You pay for 4 or 5 copies of that application, but it's for that short period of time. You're not running something all the time. There is also the consumption style plan also has a fairly large free grant. So if you want to play around with functions, you can sign up for or you can set up a consumption plan, and you can do quite a bit of playing around. And at least for me, I have a few small, just kind of maintenance style things running on my Azure account, and it costs me nothing to run them because I never go through that entire free grant. A couple other little features that we're not gonna go through necessarily too carefully. Durable functions, by default, functions are stateless. If you need something is stateful, say you need human interactions or monitoring, or like a fan in, fan out, or a fan out, fan in pattern, durable functions does let you do that. It keeps track of state for you. If you're doing a web app, proxies become very useful. I recommend this fairly often. Serving up something like a spa app in functions is mildly painful. So what that lets you do is say, I can maybe keep all my Angular code in storage and pay the lower price for storage, and then serve it through the same domain as my functions app and have the functions app be the API. Last point, logging. You can bring your own logging if you want to try and integrate it. It's fairly tightly coupled with application insights under Azure Monitor. So as with having a storage behind it, spinning up application insights with it is optional. I don't recommend not using it. It also has a free grant of 5 gigs per month. And if something goes wrong in your application, you don't have application insights running, it can be very difficult to diagnose. Right, so why F# on Azure Functions? Give me 1 second. There's some my thought process here is there's some very common best practices that are used in Azure Functions that are kind of the same concepts as what's used in F# and functional programming, but on kind of a bigger scale. So when you're building functions, you want them to be small. And then, so, you know, you're taking a full process and you're breaking it down to individual functions. Both functional programming functions do that. Then in order to make a bigger system, you chain them together. In the case of functions, a lot of times, unless you're using durable functions, you'll use either HTTP or some form of queue system to be able to pass the data back and forth. Once in a while, you might use a database, but queues are pretty common. Functions, as I mentioned, are stateless or should be stateless. I get questions once in a while about things like saving files to the server. You need to avoid that when possible because of that dynamic scaling. If I save something to the server, functions spins up another copy for me, I've lost access to that data, right? So store it outside of the functions app, keep it stateless. And this one is kind of mushy in F#, but there are definitely some areas. We'll talk a lot about, when we get into the examples, about things like nulls and handling nulls. One of the things that people like about F# once they get kind of adjusted to this fact is that the option type, which is the null type for F#, forces you to handle that no data option every single time you use it. You don't forget null check in F#. So, you know, it forces you to think about what happens if something goes wrong, what happens if the data's not there, right? On the function side, this is something you also need to think about when you're building them. If I have a function that takes data from a queue and writes it to a database and then does some other stuff, right? It writes stuff to the database and then fails. Most cases, it's configured, that system's going to be configured that the queue is then going to hand that same job to another function. If I don't double check and see if that data has already been written to the database, now I've got duplicate data because it's going to try and write it again. So it's something to think about. It's good practices anyway. In this sort of system, it can pop up fairly easily if you don't. So some of that kind of talks about advantages. Specifically, why I think F# is actually a fairly good language for, and function, they work good together. You know, F# is a good language for functions. Functions is a good way to play around with F#. So you've got multiple different choices of language under functions. Kind of the big three are going to be C#, Python, and JavaScript. Both Python and JavaScript have started supporting functional style coding, but they are still object-oriented first. F# is the only functional first language that we support out of the box. That being said, we do have a preview feature where you can kind of functions with bring your own language. So Go gets asked for once in a while. You don't have to wait for us to write a Go functions library. You can bring it in yourself. It does happen because you have to bring it yourself. There's some extra work to do that. if you wanted to use Elixir or another functional language versus F# being fully supported inside the system already. One thing that I think is really useful with functions that for testing it out, F#, kind of going that other direction, because of the nature of functions and them being stateless and being small, you actually don't have to commit to a single language. So I can have two different function apps, and one can be in F# and one can be in C# or JavaScript or Python or whatever else you're using. And they can talk to each other because most of my communication is going to be in something like JSON. Going from one language to another becomes much simpler than it would be in something like a monolithic system. And to that point, if I'm consuming from a service bus queue, I could deploy a F# version of the function app and a C# version of the same function app, and they can consume from the same queue, and you can actually test them out in real world tests, see which one works better, and things like that. And last point being, just in general, don't have hard data to support this. This is mostly anecdotal, but it kind of does make sense. The points before about functional being easier to test and having fewer bugs. Specifically in F#, the compiler is much stricter than the C# compiler. So you can have things that you forgot to test it, you forgot that null check, you forgot to test it, goes into production, whoopsies, I have a bug. F# it won't even compile. Doesn't matter if you forgot to test or not, right? It's just not even going to let you compile and deploy it. Real talk, along with those advantages, there are some downsides to it, mostly related to the fact that F# is not as popular as a language as quite a few of the others. One being the tooling is not quite as good for Visual Studio. There is a very passionate F# community, and they have created an extension for Visual Studio Code called Ionide. I haven't played around with both of them a whole ton, but from what I understand, it does come with a fairly good IDE environment in that point. Second point being, yes, you have access to everything in .NET. So you can bring your favorite libraries with you, but F# types and C# types are usually different, even when they're named the same thing. By default, a C# list and an F# list are actually two different types. So when you're bringing in a .NET library, sometimes you have to do a little bit of extra massaging if you want to then bring that into an F# style of coding. Because this is so common, F# does support this fairly well, but it is something you have to think about and consider and handle. And then last point being, somebody has to support it. Do you want to be able to take a vacation once in a while? And because it's not a popular language, finding somebody who already knows it or finding somebody willing to learn it can be a little bit more challenging. Just any non-popular language is going to be like that. Right. So setting up project, setting up your environment. This is kind of the list of things you want to look for. Like I said, we'll have the deck at the end, so don't panic if you don't have all of this stuff. There's two template libraries for you that have both C# and F# templates in them, so they're useful to have installed. You don't need the templates, but it does make it a lot faster when you're creating a function. Even with functions, there's a little bit of boilerplate, and it'll help you get that set up for yourself. Visual Studio, of course, you want the Azure Functions extension, the Ionide extension I mentioned, and then either Storage Emulator or Azurite. Storage Emulator being the old project, it looks like we are moving to recommending Azurite instead. It's open source, and that's what we're going to continue supporting. So you can just add that as a Visual Studio Code extension as well. And then the last point being, you won't necessarily need this, but it's helpful to know. We may have changed this, but when I first set up functions on my machine, whatever language you used first for a functions app becomes your default. So if this is your first time running functions and you set up an F# project and it sets your default to F#, but you use another language more often, that is the path to get into the settings and change what the default language is for your IDE. Won't change the one necessarily for your project, but it will change which one it uses for a new, uses by default for a new project. Resources, I will pull this back up at the end of the thing. Just some blogs that are really good, our documentation for functions. Call out to Aaron Powell, who is a developer advocate with Microsoft, who wrote the blog posts that I used very heavily in how to set up one of these projects. You can try it online, and then the full GitHub repo that has PowerPoint and code. So, let's get to here. All right, so setting up a new project. I'm gonna pull up Visual Studio Code, assuming I've already got that fun little list going. My computer's probably screaming a little bit about having so many copies of IDEs and things open at the same time. So the functions extension, it does let you create a new project and create a new function from here, and also let you deploy from here. Tested this about 5 minutes before we started. F# wasn't actually one of the options for new project. So you do want to use it from the command line. Once you're in F# though, this new function, create function app, or create function, will give you an option of all the installed templates. That's where having the libraries I had listed earlier really helps out. So we need to do this from the command line. It's not too tough. New func, language, and we want to name it, was it new F# functions, doesn't matter, right? Hit enter, and it's going to set up a new F#. Oh. Let me see if I can make it bigger. See if that can.
Well, for me, it's fine, but I've got it on a huge monitor, so I just wanted to make sure everybody else is okay.
The old control zoom in isn't working for me. I'll have to figure out how to do it in Visual Studio Code. Change the terminal twice. Anyway. So, but it's .NET new func language. If it's having a hard time seeing it, .NET new func, and then the parameters in PowerShell are language and name. So C# is C#, Python is Python, F# is F#. That's actually only going to pull up a couple files for you. Host.json, which has some information for the host process, as you can imagine. Local settings, this is your functions version of an app.config file, if you're used to using that. And your project file. One thing that coming from a C# background and everything being done for me, that was a little bit painful until I got used to it. When I'm making new functions, they're not going to automatically get added to this project file for me. I have to do that manually. So it is something that you have to get used to, make a new file, add it to your project file. I suspect one of the major reasons for this is that unlike C#, when you define the order of your files, the compiler works, thank you. Okay. The compiler just goes top to bottom. So if you don't have them in order, too much. If you don't have them in order, it's not going to compile. Just an extra step, but it didn't take me very long to get used to that. Right, so back to here. If I want to make a new function, now this is going to, yes, I want to initialize for VS Code. That just sets up like the debugger and things like that. Okay, here we go. And all these triggers are from those projects I sent. These will set up for me. Let's do HTTP. I don't care about the names or anything. We'll go through kind of this boilerplate code here in a minute. But this just sets up kind of the default code for me in the language of my choice. Saves me a bit of time when I'm building out a new function to not have to write some of this stuff. So now we've set up a project, we can go home. Anyway, so 20 minutes left. All right, so I've got function app in C#, and I've got the same function app in F#, and we'll go through these one at a time and kind of take a look at both of them, as many as we get through in the next 20, 30 minutes, however long you want to hang out. I'll stop at 20 minutes. People want me to, at 8 o'clock, if people want me to keep going, I'll keep going. So you will notice I'm using Visual Studio versus Visual Studio Code. That is personal preference. You could use either one for either language, it doesn't matter. The templates still work in Visual Studio. It's just the tooling is slightly better in Visual Studio Code. I can see it here, I have it. No. I moved it, so it's not going to work. If I had it set up correctly, I could load it here and it would all come up. I could debug it, everything would be fine. So looking at first function, we're going to do our basic kind of hello world style thing, just for the sake of kind of nostalgia. So there's a few things going on here that having this nice simple function lets us look at really easily. One is when you're setting up a function, it's static, it doesn't have to be. By default they are though. Function name is annotated here. This is used in the case of like the HTTP trigger. If you don't set a route, that's going to define the route, is the name of the function. These have to be unique and they do not have to match method name. I can name my methods whatever I want. Functions, once this compiles, is going to actually use the function name. And the other thing that functions uses is this annotation here. Everything, data coming in and out of the function is all called bindings. This is my input binding. You must have at least one input binding because the function needs a reason to start. In C# and in F#, so .NET, we do that primarily in the constructors. If you're in, I think, every other language, I know JavaScript and Python do it this way. I don't know about like PowerShell, but I imagine so. These kinds of things are defined in a function.json file instead. I personally prefer this way, but that's how it's going to work. This logger gets passed in every time, and that's what sends data back to application insights. So those are kind of your main aspects of it. In this case, for HTTP anyway, it's kind of using MVC. If you see my usings up here, so we can just return our object result. We don't have to have a special output binding for it. And then of course, if I go out to Edge, because of course I'm going to use Edge or Blue Chrome, I guess.
Because the new Edge is awesome.
Because Blue Chrome.
Right.
Also the fact that for some reason working on these projects, Chrome doesn't like it, so it kept locking up on me. Uh-oh, did my function app stop? You know what, let's restart it, just in case. Well, things never work right on the demo, right? Started it. Give it a second here. Uh-oh. This is what I get for making last minute changes. 2 seconds. Cosmos DB expects, some of these are in Cosmos, and it expects a lowercase ID, not an uppercase ID. Free preview. I used it as I had it as uppercase, and it didn't give me the data structure I wanted. So
Nice.
Nice. I could use annotations, but you know.
Right.
Why not? Why not just be lazy? All right. So all this fun stuff. When you're locally debugging, you get all this fun stuff. This is actually the host process. You wouldn't normally see this online, but it hopefully gives you all your API endpoints. Like I said, it's in this case we're on localhost, and then the API endpoint is designated by that function name. In your host file, you can change this API endpoint. It doesn't have to be named that. So if we go back, hopefully this will work now. Oh, come on. It's on 7071. Of course you don't want to work. There we go. After a very terrifying delay, we get our hello world app, right? So let's take a look at the same one in F#. In this case, very simple function like this, and mostly talking to the functions host. It actually looks almost identical. Few changes. The brackets here are actually define a list in F#, so we had to add a little bit to change it, make sure it knows it's an annotation. Otherwise, the arguments are all identically the same. We have our HTTP request, we have our logger, and the same two things. Because these are C# classes, again, it's letting me use parentheses. If I want to do kind of the traditional F# thing, which is no parentheses, I can do that. It will still work just exactly the same. So it is flexible like that. You get to use what's more comfortable in that case, right? So, how did Chrome come up? So again, I have this running by default. It always runs on 771. I have this set up to run on a different port so that we can look at it at the same time. Same stuff going on down here. And now we have the same message, but from F#. Okay, so very simple thing. We're going to skip the second API example, both for time, because it's not my favorite. We're going to go into data processing, which is kind of where it's great for both functions, and it's functional programming that's the thing that everybody loves it for. So for my scenario that I came up with, I always do Twitter, so this time I decided to use the GitHub API. And we're going to go take a look at the issues in a repository that I'm very familiar with, because I work on the docs repo as well for Azure, and we look at every single issue y'all put in individually. Human being looks at it. So let's say, for example, I want every day, I want to know things like how many open issues I have. I want to take a look at these individual tags. If you kind of look at our tagging structure, we have things like priority, we have service, we have subservice. So there's a lot of structure to these labels. I can get a lot of information about what's happening in my repository from those labels. So C# model is nothing too mind-blowing. Got ID for Cosmos. Cosmos DB requires an ID property, requires it to be lowercase, which I found out this afternoon. I've forgotten to do that. Source, we're just going to set that to F# or C#, so we can determine. Entry type is just for, again, which step in this demo we're at. timestamp, as you can imagine. And this is kind of the meat of it. Of what we're going to work through is how many open issues we have, are we missing tags, and then making use of those priority and service tags and trying to get some additional information about what's going on. So in C#, we set this up to once a day. There is a handy dandy admin HTTP call you can use to trigger your timer functions manually, so we're not all sitting here for the next 24 hours waiting for this to fire. And this is, here's where you get our first output binding, which is, again, I'm not going to set up a connection to Cosmos DB. Just going to tell functions, I want this database, this collection, this is my connection string. Go take care of it for me. Go do the uploads. Even though we're only doing one, I know I have this as a collection. The single document version is not async. But there's no reason you can't use this and just put one single document in it. So quick overview, walk through how this goes. I'm using a library called OctoKit that helps with working with the .NET or with the GitHub API. I'm using it in F# as well because it is very useful. Set up the client, set up our request here. We're going to do maximum page size in GitHub is 100 issues. I only want one page for this example because for the sake of my API rate limit, I think there's about 2,000 open issues in this particular repository. So if I have it pull all pages, we'll run through my API limit fairly quickly. Issues, and we want them to be open, right? So add the repository and go get our search result. A little bit of logging, what our count is, and just for my sanity, when I was working on this, how much my rate I have remaining. Finally, we go ahead and make our issue data object. Now you notice in this first example, I'm going to skip a couple things, right? We're just going to have our open issues and we're going to have our missing tags. So when we upload this to Cosmos, these two properties are going to be nulls or empty arrays, essentially, once it goes into JSON. And then finally, go ahead and add it to our collection, and functions takes care of the rest of it. Again, you're just, for the sake of completeness of talking about it, you're returning a task here. We have no, unlike the HTTP, we have no return object. We're just adding it to this collector. It depends on your output binding. Some of them have return, some don't. Right, so does when we're running on the admin, you have to be a post request. So we're going to run that on Postman. And use our handy dandy storage explorer. And here it is. Docs repo, documents. Refresh this, and we've got our result. As you can imagine, with so many documents, we limited ourselves to 100. As expected, there's none that are missing tags, thankfully, and we left these two as null for now. All right, so hop back to F#. So this is a record. These are types in F#. They're generally known as records instead of classes. They are immutable. So that's where there is no constructor here, and there can be no constructor here, because when you make a new object in F# or a new record in F#, you're going to essentially your constructor has every property in it, and it's the only constructor you can have. You only get the one. You can add functions and some other things to it. This is very simple. It's just a data model, so it doesn't have any. There's a couple other things that are different from C#. We have a couple of union types. This is very similar to, it's not an enum, but if you're looking for something that you may be more familiar with, it functions in kind of that way, where you get only a set number of values, and you have to pick one. Interestingly, we talked about nulls not being the same, and this is actually how nulls are handled in F#. You have the option type, and you either have something or you have nothing. So it makes it easier a little bit, like I said, to be very, very specific about what you're doing, as opposed to being that reactive programming style. So when we look at the class now, source instead of source, it's one of these. I either get C# or F#. Those are my only two options. We're always going to be sending F#, but if I was consuming that data, I want to be able to consume data from my other functions app. And then entry type is the 4 examples that I have here. Save that. See here if I've got this pulled up already. And go away again. Save space. That's the right file. Here we go. So again, annotations are about the same. They got cranky when I tried to do this on multiple lines. You can do it because F# is primarily denoted by white space. It is a little bit pickier on that particular item than C# is, where you can put new lines and where you can't. But other than that, this is all exactly the same. Input data, output data, and our logger. Just for async, it has a completely different async system. Again, you can use tasks, but in order to determine an async block in F# as opposed to a single statement, you use this particular function. And then for functions, because it's in C#, we want to start that async block as a task instead of the F# standard processes. I've got 4 minutes left. We're going to get through this one. Anyway, so this is pretty much all the same.
If you run a little bit longer, that's okay.
Okay. So this is pretty much all the same, right? We get our token, we create our client. Little bit of F#y stuff when we're creating our client. Excuse me. In F# you see this pipe operator a lot, and that just means take the return value from this function and then pass it into our client function. This is also a little bit what happens when you have mutable values. In this case, it's a C# property. We want to assign to that. So we have to do that. It looks a little bit different. And then we have no return statement. We're just going to return the client. If we didn't have this extra thing in between, we can actually remove this and just have it be this one line, and it would return the client from there. Okay, so build out our issue request. This comes back to, this is where things like interfacing with C# takes a little bit of extra effort. C# you don't have to define whether or not something is nullable. It'll automatically take care of that for you. In the case of F#, anything that's nullable, anything that's mutable, anything like that, you have to be very specific about. But it's not too bad. Like I said, you're just telling it that, yeah, this is nullable, that's fine. Repos.add is the same. Again, C# style syntax is fine for C# style code. And then here again, we're awaiting a task because that's what this request is going to send back. A little bit different, no await, we just have this exclamation point here. Blah, 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 same logging. Another spot where we're converting types a little bit. This makes it an F# sequence. Most F# collection types are separate from the C# types and don't necessarily behave the same. Sequence is a bit different in that it implements IEnumerable. So lazy loading, a lot of the same things that you're familiar with, how it actually works behind the scenes is very, very similar. And you actually can use link on it if you really wanted to, right? So if you want to kind of do that mishmash, yeah, you can go ahead and pull in link and run link on sequences. We're going to go ahead and use the sequence function and pass the function into our function. And just, we want the count of, in this case, we want the no tags, we want the count of ones with no label. And then a little bit different here. Again, we're just instead, creating all those same items. Sources F#, we're count only. Our no tags, we want to get the length of that, filter down. This is where it gets a little bit different. Like I said, we still have to put in those properties, but we have to say, no, we really want them to be null. We really want them to be empty. And then a little bit different here as well. I could just put this in the output data, add async. Unfortunately, Newtonsoft doesn't quite serialize some of the F# types prettily yet, if I can use that word. So we're using a specific serializer that sits on top of Newtonsoft that handles some of these types a little bit more gracefully. And then that is one difference. When you look up here, instead of the record type, we're just passing that back as a string. Cosmos handles that just fine. It gets translated to that anyway. So if we run this on our different port, we're going to get pretty much the same thing. There we go. We have a 202. Does take a second. Maybe it's just too fast. Yep. So now if we look at this one, ID, C#, count only, blah, 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 everything that we expected. Pretty much exactly the same thing. All this underscore stuff is Cosmos things that it needs to do in order to do what it does. Pretty much never set them. You can generally just ignore them for most purposes. We don't have the null values here because that serializer handles it. But things like the source and the entry type it handles for me. All right, we are at 8 o'clock. I will keep going if people want me to keep going. I will pause for questions. I can stay as late as people want. You can do your
Is this being recorded?
Yes.
Yep.
Okay, great.
Oh, let me make sure I get this pulled up again. Oops. For everybody, this is always a question. Where's the PowerPoint? So Ken, what do you think?
Well, how about a show of hands? People want to use the little hand thing, and you want us to go a little longer, or are we at a good stopping point? Hands say we keep going. Has some questions for Samara that they want to go over on any of the things we've covered today so far. We'll hang around.
Anybody want to break in while it doesn't seem like anybody gave people a chance for questions. I don't know if anybody wanted to break in while we're still kind of in between things with questions. Otherwise, I said I'm happy to go through the rest of this demo for people so we can record it and for people who want to stay.
Yeah, I have a quick question on this one.
Yeah.
What are the diagnose and problem-solving option available for these functions in the Azure?
So pretty much everything, I mentioned everything goes to application insights. Functions, the host process does do quite a bit of just base level logging for you. So just kind of a high level, if something fails or something like that, it'll take care of that for you. If you want to know some of the details about what happened inside of your function, kind of your custom code, you have this logger item that goes to application insights as well. And you can, it takes a little bit of care, but you can also get the application insights client inside your functions directly if you want to call those methods for things like events or things like that. You just have to be a little bit careful that you're not creating a new client. You're using the same one as the host process. I don't know if I have a good example that I can actually show you that has a whole lot of logging in it. Let me see. I haven't messed around on my personal account with functions in quite a while. I do it a lot at work. But of course I can't show you those. All right, let's see what I've got for application insights. If you've never used application insights, it does take a hair of getting used to kind of navigate. I'm not gonna lie, but yeah, you can see I don't have any data in it. But you can kind of see the kind of things that it takes care of for you. The host process will take care of things like failed requests, server response time, server requests. You can put in availability tests. All that kind of stuff kind of comes out of the box. And then there is you can go ahead and there's a full query system in here. You can actually go in and access all the specific tables. Most of the functions data sits here in this custom events table. You can go ahead and query this. It's Custo language, which is SQL-like. But yeah, so quite a bit of logging available to you. I have talked with customers as well who used one of the other logging frameworks and they just integrated it with functions. I do still recommend turning the App Insights instance on, but you do have the option of kind of bringing your own. Does that answer your question?
Yeah, thanks.
Awesome. Yep. Any other questions before we go dig in?
Yeah, I had a quick question, Samara. Very nice presentation, but so most of us are using .NET Core for functions. Is this something we could deploy into like on the server, like serverless functions onto Kubernetes or KDA, for example, with F#? I'm referring to F# because you mentioned that today.
Yeah. So F# actually, once you compile F#, it's just a DLL, same as C#. So the biggest thing is that, like I said, most, including the functions host process, is expecting a C# style response. So when you're talking to the host process, you will sometimes have to keep that in mind with your return value, your final return values. But a lot of times they just get serialized anyway. As far as something like Kubernetes, that's a fairly recent thing that we started letting people deploy not only their app, but the entire host process to Kubernetes or a VM. I have not played with it yet, so I don't know the full state of it is.
Yeah. I guess my question was, is F# something which is similar to, so is it like .NET Core or?
Yep.
Okay. So it can be deployed to any kind of operating system.
Yep.
Okay, cool. Thanks.
Yeah, no,
it's still a It's still a CLR language.
Okay.
Like I said, it compiles to a DLL, same as C# was. The CLR doesn't care.
Okay. All right. Thank you.
Any other questions while we're going back and forth?
Todd, I see your hand up. Did you have a question?
Or is he still voting?
Okay. His hand went down.
Okay.
Hey, I had a question.
Mhm.
I was curious about local development when you're like, running the function locally and you're connected to Cosmos DB and do you end up having to use like resources in Azure to test? Generally, when you develop locally, you try to set up a full local environment kind of thing. But it looks like with functions, you don't typically do that. Is that correct?
It's going to depend on what you're connecting to. More and more services in Azure, like Cosmos, have a local emulator. For storage, for example, I'm using a local emulator. I'm not connecting to a storage account in Azure. I chose to do a Cosmos account in Azure mostly because I haven't played with the emulator and I don't know if the two will talk to each other. In some other cases, like Service Bus, which is a really popular choice, there is no local emulator. You're kind of stuck.
Got it. Thank you. That makes sense.
Sure. I have done functions in the past where, kind of to that point, I kind of kept the guts of the function in all the business logic in one method, and then the service bus call was just kind of a wrapper around that. And then I could also either use that magic admin link that I used for the examples, or make another wrapper that was an HTTP function and call it that way. It doesn't quite go through the whole process, but it does save you a little bit from always having to go back and forth to service bus. Okay. Anyone else? Fun questions.
Hey, I wanted to just ask a question.
Yeah.
So, is there a way to set up monitoring for a specific SQL query?
Monitor for a specific SQL, just to make sure I heard you correctly, monitoring for a specific SQL query?
Yes.
Do you want all of your SQL queries or just a specific one?
Just a specific one.
I think if you want just a specific one, you're probably going to have to do some manual configuration inside your function to do that. If you want all of them, application insights, there's some settings you can do to just have it capture them all, with the understanding that you have to handle things like PII on your own. Yeah. And I had questions I don't remember off the top of my head. But Application Insights has the ability, I haven't done it with functions, where you can kind of pre-process the data that you send up to it, where you can have that SQL query, but remove the PII before it goes to App Insights. So we never get it. It's all contained on that machine. Yeah.
All right, thanks.
Mm-hmm. Anyone else? Lots of, like I said, lots of fun questions. These are fun. I do, like, it's my job, so. But hearing a resounding silence, I'll pull Visual Studio back up so I don't hold you here all night. All right. And do still feel free to interrupt if you feel like you want to do that. I think I'm going to skip the second one because second and third are very, very similar. So for the next example, what we're going to do, we're going to add a little bit to it. We're going to get those last two items. So all the boilerplate, all this code is the same. Nothing too spectacular here, as if you're used to C I do have a private function down here. Pull all the labels, and then here's the label check. Ah, yeah, it's this. So in this case, priority. In this case, we're looking for the service tag. So looking for those specific labels, group by, and then get the counts. So when we run that one, get back to C#3, give it a second. Looks like it finished. All right, so priority, we got out of those 189 that are priority 2, 11 that are priority 3, and then the full list of all the different Azure services that are on that one page. Looks like mostly Azure Monitor, which is a big one, and Active Directory. Those are always pretty high, right? So flipping back to F#, which is what you're at least partially all here for. Get rid of this terminal. Again, up until here is the same. And then we're going to go into kind of the F# style of link. Blah, 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 blah. Oh, live streams. Yes. There are live streams, and the application insights live streams are available also for functions. They work about the same as they would for a regular app service. Anyway, so very, very similar to what you would see with link. We've got our sequence, our IEnumerable, and as is very familiar to you, count. There's a, just so happens in F# sequences, there's this count by function, which is essentially a group by and a count at the same time. Link by default doesn't have it. I did see that there's a Nugget package that kind of adds that as an extension method. Handy dandy little thing. But basically, we're passing in a filter. We've got our tag filter up here. We want to find the one that has our priority label or our service label in it. And it's going to group and count by that label. Did it pretty much the same here. I just did collect instead of filter. I remember correctly because I did this very late last night. Collect is just oh yeah, this is the select many essentially for labels or for sequences. Filter, count by, and so now instead of none, we have to specify that we have some data instead of no data. And then because my type is map in my record here, I have a map instead of sequence. Just have to do a cast back over to that. And there are, for most of these types, there's going to be, and casts have to be explicit, but for most of these collection types, they are built in. You just have to call a function on it and it will do it for you. And then we have our serializer at the end. So looks fairly similar at this point because we're mostly using link, or which is very similar to kind of the F# style, and just the defining some. We have data instead of no data. It's forcing us to kind of define that null type essentially. All right, so if we run that one, there you go. Into the summary, what it looks like. Again, it's gonna look about the same, right? We've got our count by service, count by priority. We got the same output between the two different styles of programming. So last example that I'll go through, we're going to do something a little bit fun. We're going to take so I've got a service label, and in some cases, we've also got a subservice label. So I'm going to actually run this first, because I think it'll be a little bit easier to see what I'm talking about, which is to nest that subservice counts into the service counts. So a little bit heavier data processing at that point, doing a bit more fun stuff with it. So in this case, under Azure Monitor, we do have 9 issues, but 3 of them are logs, 3 of them are application insights. 1 of them doesn't have any underlying tags, 1 is for alerts. So you get more information about what's going on. So we're taking an array of arrays and kind of doing this nesting thing with it and rearranging our data. If you want to figure out how to do this in a single link query, give me a PR and I will probably put it in. I did not figure it out. And it also, I think, to do this kind of by hand illustrates, I think, a little bit kind of a C# style of coding versus F# style of coding. So holy null checks, Batman. So the approach I took here was to just loop through the items and kind of find our service label, kind of create our dictionary as we go. Real quick here is a new model. We've got an item code, which is just name and account, and it can have children for our subservices. Theoretically, if I had another layer, it would go ahead and handle that instead of our dictionary. Right, so anyway, so back to this. So yeah, we're just checking if it's in the dictionary. I use the dictionary, at least for this first one. If it's in the dictionary, just add 1 count. If it's not in the dictionary, add it, which is a fairly common process with converting lists like this when you're not using LINQ. And then another layer when we are doing our subservice, once we've got the service label, check for the subservice label. And we know that this is in the dictionary now. So we can go pull that, pull the children of that service, look for that name again, and then try and find it and add it if it's there, or add it if it's not there, add to the count if it is. And then nothing special here, just making the object again. So fairly long and involved process of telling C# what I want it to do and how to do it. Whether that's the best solution or not, it works. Send me an email if you disagree with me. Probably is not. So F#. One thing you'll notice here, and again, this isn't necessarily the only way to do this. Whereas I had this big, huge nested lists and all this stuff, where I go by service here, it's a single statement with a lot of pipe operators, but no list, no messy messy loops or anything like that. We're sticking with kind of that LINQ style, even if we don't have all the operators. So for the sake of my sanity, make the rest of this code a little bit easier. It's maybe not the most efficient. Was to just create a tuple that has the service name, if we have one, or unknown if we don't. Again, handling that null case explicitly. And then looking for the subservice if we have one. In that case, it's still an option type. We don't always have to have data there, but in that case, we're going to go ahead and let it have no data. We're going to leave it as an option instead of getting rid of that situation. As you can imagine, group by, same as you would do with a link query to kind of get it into kind of that key value thing. Words are failing me at the moment. And then we're going to use this map function. This is kind of like a select, pass in a function that's going to define, this is our record type for our service counts. Again, we did define a new type. We have service and we have subservice. One of the nice things that you'll see a lot in F# code, because these quote unquote class definitions or type definitions are so short, you'll see a lot more special purpose classes or types, records, whichever you're using, because it's one line. So why not? It comes back to things like the union type that I had in here. I don't have to create it. I'm not creating a whole nother file just to have these 4 values. It's just a one-liner thing, right? And it figures out based on the properties that I pass to it. I don't even have to tell it which object I'm using or which record type I'm using. I can tell I'm a C# dev because I keep using the C# types. I don't have to tell it which record type. It's going to figure it out from the property names. So this is just cleaning up the service name. Get rid of that tag. Name, count. This looks exactly like our link queries earlier, where we were doing a group by and then the name and the count. Where it gets a little bit different is in getting those subservice counts. Now, instead of doing an inner loop, we're going to go ahead and pipe it in right from where we were. It's the second half of this tuple, right? So when we're in this group, we already know we have a collection of all these subservices that are the second item of the tuple. And at this point, because we don't care about the values anymore, we just care about essentially the key and the count, we can go back to using that count by function and map that back to our name and account. Again, because we're allowing this to be empty, we have to explicitly tell it that it's okay for it to be empty and what to do with that case. And then just cast it out. The type that ends up coming out of this is a little bit different than the type that I had defined. So we just had to, I just did it in a separate function for the sake of my sanity, because we're getting a little bit long. And basically all this does, this choose function, essentially just removes nulls. And then casting that out to our list and saying we have some values. So it's just, what we got out of it was a sequence with an optional subservice, and we want a list of services that is optional. So it's just kind of moving that null check out. Finally, to list, we have some data. Here we've still got the old definition, but here we've got this new thing. And you know, kind of that idea of functional programming, right? I can just walk through this. Everything is, I could improve this a little bit further. I could have this be a name type instead of a tuple. So I could get rid of these first and second functions and have it be very explicit whether I'm using the service or subservice. I didn't do it, you know, you could keep improving on this, making it more and more readable as we go along. So again, if we run it, oh, it's the one I already ran. What it prints out is this nice nested list that I had already shown you, where we know both the service counts and the subservice counts. Fairly straightforward. I don't have to worry about forgetting a null check. It's all built in. And again, because this is all serialized into JSON, I can go ahead and then consume this record back in C# or F#. Doesn't matter. You know, there's none of that interplay that you often get when trying to combine the two languages. Right. So that is the end of the example code. Just like I said, putting a few more layers onto that first example, making it a little bit more complex. So that is the end of the presentation, the example code. Again, it's all on GitHub. I did skip the second API example. That one's a SQL call, which is not particularly different from what we've already been going over in this data processing example. Functions doesn't have an explicit binding for SQL. I'm not 100% happy with how that turned out in F#, so I may go adjust that later as well as I get time. All right, one more round of questions for everybody. Only 40 minutes over.
It's not over if you intend to go that long.
I did not intend to go that wrong. Usually I go short. This is a new experience. All right. Hear a bunch of silence. I suspect we got through most of the questions in the first round.
You've melted their brains.
It was, I think I mentioned before, this was personally, it was a very, very interesting exercise to go through. I enjoyed going through it a lot. I learned a lot. So yeah, I hope you learned something too, if nothing else. I kind of enjoyed putting it together for you.
It was pretty great.
Yeah. So
enjoyed it very much. And thanks everybody who stuck it out to the very end. I hope you got a lot out of it. We'll have the recordings put together and set up on our YouTube channel here probably sometime tomorrow. And we'll see you again next month. We'll be doing Xamarin and have a member of the Xamarin team presenting.
Yep. I'm sure Ken will send out the link. I will add it to the PowerPoint, this slide on the PowerPoint as well.
Yeah, any links that that you have for your repo and stuff like that. Let's add that to the meetup chat, just so it's in context with that meeting. And then we can also add that to the YouTube listing as well.
Here, am I trying to add something to chat from one computer onto another computer? I keep trying to do that, move my mouse like I have multiple monitors going instead of 2 laptops.
It's going all Inception.
Yeah. All right, I'll post it here in chat.
Stop the